Okay, Dana.
Thank you. Thanks, Julie. Hello, my name's Dana Garves, but it's okay. People get the last name wrong frequently. I am a chemist and owner of Oregon BrewLab that I started in 2014, just wanting to provide affordable, fast, and TTB accurate ABV testing. I now offer over 20 different assays for a plethora of different beverages. Today, I want to talk to you about what green chemistry is, sort of give you a small background. Then we're going to go over the 12 principles of green chemistry and then how to apply them to your ASBC methods, sort of the broad strokes of ASBC methods that I think we find most commonly in beer labs. And then lastly, I'll provide you with tons of resources and tools so that you can do this in your own space. Starting off, what is green chemistry? The ASBC, or sorry, the American Chemical Society says that green chemistry is the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances, right? So green chemistry applies across the life cycle of a chemical product, including its design, the manufacturer, the use, and then ultimately the disposal of that chemical product, right? So put simply, it's a set of guiding principles that reduce environmental impact of chemical industries. And since beer is a solution, that means beer is chemistry, and therefore we can apply green chemistry to the process of making beer and the process of testing beer quality. Just a smidge of background here. The 12 principles were created in 1998 at Yale from Dr. Paul Anastas and John C. Warner, with sort of the idea of making sure as we enter into this like new millennia of chemical processes that like we are paying attention to our environment as we create new technologies. Right, so the early 2000s really saw green chemistry adoption into undergrad programs across the US, which sort of ushered in this whole generation of chemists who sort of inherently integrate green chemistry principles into whatever chemical profession they went into, including this youngin who's been slinging green chemistry for over 13 years. This is something I've been very passionate about, and hopefully I can convince you to use some of these ideas in your own lab. What green chemistry is not is all or nothing. If you are able to use just one green chemistry principle in your laboratory, that is a huge success for you, for your budget, for the environment. But if you are unable to use all 12 principles, that's okay. It doesn't mean you're a failure, right? These are not hard and fast rules that you need to adhere to. These are guidelines that help you slowly take baby steps to a more environmentally friendly laboratory, right? And sort of in that same vein, this is not a cure-all. We are not going to suddenly fix global warming if all of us here today use every single green chemistry principle we can. That responsibility is withheld for the top 10 companies in this world that pollute the most. 90% of all pollutions come from only 10 companies. So that will be the cure-all, is when they're held responsible. Along these same ideas is this is not a meter stick or a measurement of your environmentalism. Please don't compare your lab or your process to someone else's. They may not be as far along as you or have the budget to be as green as you. And similarly, if someone's able to do more green chemistry than you are, that doesn't mean that you're a failure. So this isn't a way to measure, oh, I am able to employ all 8 of the green chemistry principles. No, any step is a good step. And then lastly, this is more of a personal takeaway, which is that green chemistry is not limited just to chemical processes. I apply these types of ideas to my kitchen, to my office, and I implore you to apply them to your brewing process, to your kitchen or your pub, or just to your general life and how you look at things. Okay, so let's dive in. Let's look at the actual 12 principles of green chemistry. The first one seems very obvious, and hopefully that is to you. It's number one is prevention. We want to avoid creating, treating, or cleaning up waste. We want to have no waste at all is the ideal, but if we can minimize it, that's a step in the right direction. Number two, atom economy. So we want to minimize or eliminate all of our byproducts that we possibly can. And that's kind of along the same lines as prevention. Number three, we start to get into the more kind of engineering, chemical engineering element. So less hazardous chemical syntheses. Synthetic methods should be designed to use and generate substances that possess little to no toxicity to humans and the environment. So when engineers are creating a new method, we want to ensure that the method itself holistically is not toxic to us or to our planet. Some chemical engineers design new chemicals or new solvents. And so in designing those, we want to make sure that they are safe, that they maximize the functionality of what you're trying to achieve while minimizing our toxicity, the impact on the environment, right? So number four is designing safer chemicals. Number five, safer solvents. Selecting safer solvents or safer cleaners that are better for humans, better for your lab tech, better for the environment. I think that this one's a really big one for the beer industry. And then number six, rounding out the top half of these principles, energy efficiency. So utilizing methods that run at room temperature and room pressure are always going to be preferable to ones that require energy outputs to achieve very high or very low temperatures or to create high pressure or vacuums. That requires a ton of energy. And so anything that we can run just at ambient temperatures and pressures is going to be ideal. All right, so that's the first half. Let's get into the back half here. Number seven, renewable feedstocks. So procuring raw materials from a sustainable source. I think this is one that the beer industry can utilize pretty well. Just making sure that we're choosing products that we are able to continue making and that we aren't using up our resources in selecting those fuels. Number eight is reducing derivatives, so avoiding the use of blocking groups or protection groups, temporarily modifying physical or chemical processes which require additional reagents and generate waste. So this doesn't necessarily apply to beer, but I do want to explain what that means. In a chemical reaction, sometimes we have a compound, maybe it's volatile, that we don't want to actually participate in the reaction until maybe the end stages, or maybe when a pH is reached. And so we add in these blocking groups or these protection groups that kind of coddle that volatile compound until it gets to the stage where those blocking groups are then removed and the compound's able to react within the chemical process. And so those blocking groups create waste. They can sometimes be very toxic. And they aren't reusable. So if we can reduce the use of derivatives in chemical processes, then we're preventing a ton of waste. And sort of along the same lines here, catalysis, number 9 is really important. So selecting catalytic reagents is way more superior than selecting stoichiometric reagents. So sometimes we use catalysts in chemical reactions to push a reaction forward that would otherwise take longer or require more extreme measures. So selecting catalytic reagents that allow us to re-grab those catalyses and scrub them, clean them, reuse them, that is always going to be ideal compared to a catalysis compound that gets used up in the reaction. Number 10 is design for degradation. So end of product life should always break down and not persist in the environment. This is one that we can think of in terms of I think our final product of beer, so switching from pack text to going to something that uses cardboard, whether that's boxes or 6-pack holders, or now the newer cardboard six ring clips. Those are excellent. And thinking about, plastic doesn't degrade in the environment. So what can we replace that with? Number 11, real-time analysis, pollution prevention. So analytical methodologies need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. So looking at the entire chemical process and each individual part and analyzing how that part is going to persist in the environment and keeping track of what happens over time to each of those. And lastly, number 12, accident prevention. So minimizing the potential for chemical accidents, including releases, explosions, fires. This is paramount in green chemistry, and I think one of the most important ones. I'm going to go through quite a few different methods, and I'm not always going to point out each individual step you can take to be safe, because green chemistry is more or less synonymous with safety. So all interactions with chemicals or in chemical processes require the use of personal protective equipment, including but not limited to closed-toed shoes, long sleeves or not short sleeves, nitrile or latex gloves. I think safety goggles or any sort of eye protection is wonderful. And then I think over the pandemic, we've learned how useful masks can be in terms of safety, dealing with malt dust, preventing false positives when you're doing micro. But then also just keeping yourself safe. I think masks have become more key and a larger tool within chemistry over the last few years. And lastly, I think our industry doesn't spend enough time discussing hearing loss and hearing damage that can happen in high production facilities. I know that when I have my 3 centrifuges going and the sonicators, that it sounds like a runway in here. So I like to think that earplugs are something that we're gonna be seeing more of as far as safety goes within the chemistry lab. All right, so if we kind of distill all of those 12 principles down into what I think is kind of the most useful, or what I find myself using the most in the beer chemistry lab, are these 6 principles. So preventing waste, eliminating or minimizing byproducts, using and selecting safer solvents and cleaners, using methods that run at ambient temperatures and pressures, choosing renewable feedstocks that are more sustainable, and then of course always looking with an eye to safety and preventing accidents. All right, so here we go into how we can apply these chemical principles into the chemistry lab within the brewery, right? I am going to talk about just a few ASBC methods here. And what I went for were ones that I think kind of are unanimous across the board, that even the smallest beer labs might be running these methods. I did not cover things that focus on HPLC or GCMS, because I don't think that those are as broadly used, but I am always curious and collecting ideas for implementing green chemistry. So if you use those methods and you have ways that you've reduced your waste or that you've used green chemistry, please let me know so that I can disseminate that information to others as well. So let's dive into it. We're going to start really easy here and just talk about, when we're preparing our samples, we can take small baby steps to using green chemistry. So beer 1, which is degassing methods, we can utilize filtration via paper filters. And I filter maybe between 10 to 30 beers a day, which means that I have a ton of paper waste. And so this was like really getting to me. I felt like I was generating so much waste, and I realized like I can just compost these. These can go straight back into the environment because they've only touched beer. Now, do be careful and double check the materials of your filter paper, because some of them have glass and you don't want to necessarily put that into your compost or yard waste. But I think paper filters is being in the compost is like a really great way to reduce the waste that you are generating in the lab. But we can prevent waste entirely and just cut out filtering if we do the time-honored tradition of pouring flask to flask to degas your beer. That's an excellent way to not use paper filters. Or if your lab is in a position to spend some money on equipment, a sonicator bath will very quickly get rid of that CO2 and costs only between $100 and $200. Same with the benchtop centrifuge that you can use to degas and also filter without creating any waste and having dedicated centrifuge tubes for that. Let's go into alcohol via distillation. So beer's methods for A and B. I think that one way that we can prevent water waste is to purchase a USB pump for recirculation. If for those of you who are still using an open flame to heat your distillations, I implore you to please purchase a heating mantle. They're less than $300 and they are significantly safer for your techs. And lastly, please get an oven glove or some sort of oven mitt that specifically has articulation for removing those clips, for taking down your distillation. Far too many breweries I've seen have just used a rag lying around or pulled up their sleeve to protect themselves from heat damage. I think that here for just under $300, you're looking at a $12 pump, a $200 to $250 heating mantle, and a $20 oven glove is going to do a world of difference in your laboratory. Now, even better than testing your alcohol via distillation is to test it with gravimetric methods, right? The Anton Par Easy Dens is now available to brewers for $300 to $400. It's a bit more accurate, and it is even available on Amazon. So it utilizes near infrared technology to measure your alcohols. And if it's good enough for the James Webb Telescope, it's good enough for beer science. So making that replacement is going to be much more energy efficient, right? We're no longer boiling beer for an hour or however long it takes you. We're preventing accidents by removing that pressurized hot liquid and those hot gas. And it does prevent water waste. So to me, spending the $300 to $400 on distillation equipment is not worth it if you can purchase an Easy Dens. Moving on to beer 8B, specifically titration for titratable acidity by phenolphthalein indicator. I think that this is a method that the ASBC might want to look at retiring, just because most breweries should have a pH meter already. And phenolphthalein is actually an incredibly flammable liquid and a carcinogen. So if we can remove that and get more accurate, better results, I highly recommend switching from using phenolphthalein as an indicator for TAs and moving into pH. And so you can get a pH probe that's handheld for about $100, or if you're willing to spend a little more for more stable, more accurate and precise readings, a benchtop for about $300 to $400 is equally good. Now, when we switch from measuring via phenolphthalein to measuring via pH meter, we no longer need to boil that sample, right? And so that's going to be more energy efficient, safer for your lab tech, because we're removing that hot liquid. And then lastly, it prevents a 50 milliliter water waste. And I know that 50 milliliters of water doesn't seem like we're preventing that much waste, but 50 milliliters of water in Jacksonville, Mississippi, or Flint, Michigan is a lot of water. So please consider switching over to pH meter for measuring your TAs. If your brewery is in a position where you're considering testing ash, your percent ash, and you're looking at maybe getting a muffle furnace for this, I say don't. While measurements like this are always going to be more accurate than a calculation, I think that replacing this with a calculation is more energy efficient. We don't have to get that muffle furnace up to an insane temperature, even though it might warm your lab. I highly recommend switching to a calculation because it also removes that need for your lab techs to interact with something insanely hot. And so this is the calculation for percent ash in 12 ounces. And again, if your lab is at the point where you're looking at purchasing one of these, I'm assuming that you already have the assays needed in order to measure your alcohol by weight, your real extract, and your calories. Now, those are items that you can calculate as well, and the ASBC has methods for that. You're also able to, using this equation, able to switch out that 12 ounces and that 350 milliliters for a 16 ounce, or if you're one of those breweries that have the 19.2s, you can determine your ash percentage in 19.2 ounces. Okay, we're going to spend quite some time on IBUs by solvent extraction because it has a bunch of areas that we can improve in terms of green chemistry. Now, one of the things that I highly recommend is switching from the regular method, which uses 50 milliliters of isooctane for extraction, and do what I do, which is go to the reduced solvent method. So based on a poster put out in 2008 at an MBAA conference, a student went through and measured creating IBU solvent extractions with different quantities of isooctane. And so what I use is 5 milliliters of isooctane to 2.5 milliliters of beer, and then 250 microliters of hydrochloric acid. And what that does is means that a cuvette holds roughly 3 to 4 milliliters. So I use almost all of my isooctane extraction liquid for that final measurement with almost none left over. So I'm minimizing that byproduct of extra isooctane. We can prevent waste and just completely cut out octanol and antifoam B. These, in my experience over the last decade of testing beer, are not needed. If you do your sample prep correctly, you shouldn't have any extra foam really coming up. So if we can avoid these chemicals altogether, I think it's very important that we don't even need them in the lab. And then lastly, we really want to protect our technicians from isooctane and hydrochloric acid. So a hood is ideal. This is the best step you can take, is get a hood to run your IBUs, but I have to acknowledge that not everyone can afford one. So what I recommend is getting these really excellent bottle pumps. Now this is Fisher brand, so this is a name brand pump, but there are very affordable ones on Amazon that you can purchase. And so you get the bottle of isooctane in, you set the pump on top, and you set it to the amount that you want to disperse, and you never interact with the isooctane when you're preparing the samples. And that's the same for the hydrochloric acid. I think any time that we can reduce volatiles being in an open bottle is something that's going to help protect people. And then if you don't have a hood to run your IBUs, please wear a mask to just sort of reduce your exposure. Another way that we can prevent accidents is to purchase pre-made 3 normal hydrochloric acid. This one actually took me way too long to figure out. I spent a good portion of my career diluting down glacial hydrochloric acid from its normal concentration down to 3 normality. It is a nightmare. I hate it. It scares me. It's maybe the scariest part of my job, or was, until I started purchasing the pre-diluted stuff. And those are available on Weber Scientific and Thomas Scientific. And then that way, when those come in, you can add your bottle top right on top of it and never actually interact with the hydrochloric acid. Another thing that you can do is you can switch from single-use plastic pipettes to glass Pasteur pipettes for the solvent transfer from your centrifuge tube into the cuvette. You can wash and reuse those until they break. Basically, just be sure to have a glass waste available. This idea came from Amy Todd at Zymology Lab. She introduced me to using glass centrifuge tubes for IBU extraction, and it is a really good way to, one, not have to struggle procuring plastic centrifuge tubes, but also for preventing waste and protecting our environment. So those are examples of the glass centrifuge tubes, and then also the glass pipetters. Another way we can prevent waste or minimize our byproducts is to collect our used isooctane and filter those through a chromatography column to pull out all of the isoalpha acids or isoalpha humulones that have been converted. Go ahead and pull those out, and then you can reuse your isooctane. There's a lot of resources out there for how to do that. That will save you money, that will save the environment. And I think that that's worthwhile. And lastly, I just want to say isooctane and acidified beer cannot go down your drain. I can't tell you how many times I've talked with brewing labs that have said, yeah, we either recycle our isooctane and reuse it, or we take it into hazardous waste disposal, but we dump the beer down the drain. Please don't do that. That beer has been acidified with that 3N hydrochloric acid, and it now sits at a pH between 1 and 2. Those are things that cannot go down the drain. And if your waste stream at the brewery is acidic and you're not quite sure why, it could be that your lab techs are dropping that acidified beer down the drain. So please collect your IBU waste and dispose of it properly. Oh, yep, here we go. These are some of the things that isooctane can target. So it's not a very fun chemical. Reducing your exposures is very good for your health. Just a few general, we're going to switch gears and go from the chemical assays and kind of look at a few micro assays. Just in general, in terms of when you are doing microbiological control methods, a lot of people have a flame nearby in order to create that sort of more sterile environment. When you are using a flame, please consider switching away from natural gas or propane and use an alcohol flame instead, right? Once we use up propane, that propane is gone from this planet. It is no longer available, whereas we can grow alcohol in the form of barley, corn, soy. And so using alcohol burners to create that nice environment for your micro testing is just a small step you can take to select a renewable feedstock, as opposed to using a gas that is becoming harder to come by. Okay, and then I actually really like using these glass Petri dishes. They're easy to sterilize, they're easy to clean, and they reduce all of that extra plastic waste from Petri dishes, and it's good for your budget. I used to go through Petri dishes insanely fast, and I still do now, but I use a whole lot less waste. So those are just kind of overarching for when you're using anything in micro. Please consider switching to some of these alternatives. Looking at microbiological control 3, differential stains or gram staining. I get kind of irritated at ASBC that it still recommends using tap water to rinse your crystal violet. However, crystal violet is very toxic to plant and animal life with long-lasting effects. So I implore you to please do not flush your gram stain waste down the drain. You need to collect it in the same way you collect your octane waste and dispose of it using collection services. Another way that we can reduce waste in this particular assay is to reuse your iodine. You can put it in a little container that can hold your glass slide, dunk it in, and then rinse. You don't need to use up the iodine on the slide. You can just dunk the slide in. So that's a good way to reduce iodine waste. All right, and lastly, we're going to talk about media preparation for microbiological control. That's number 5 for the ASBC methods. I have been talking about this for a little over a year now, trying to convince, and I think successfully convincing people to switch away from using autoclaves or pressure cookers to using a microwave to sterilize your micromedia. You know, autoclave and pressure cooker takes a ton of energy. You need the time it takes and energy it takes to get up to temperature. You need the release valve for the pressure cooker for 15 minutes before it sits for another 15 minutes at that temperature and pressure to actually sterilize. And then you have a 2-hour cool down period before you can actually pour the media into plates. However, if you utilize a microwave, you can sterilize that media and go from powdered media to firm plates ready for either your streaking or your cellulose in 1 hour. So not only are we being more efficient with our labor, being more efficient with our energy, but we're also being safer because no pressure cooker means no potential bomb. When I was using a pressure cooker, I was always very apprehensive about the temperature and the pressure. And I didn't really like being on the Homeland Security watch list for a year after I purchased it. Another thing that I love to compost when we can. You can compost old UBA and YPD plates, assuming you hadn't added cyclohexamide to that, which is a yeast inhibitor. This is a really great way to add nutrients and beer yeast back into the environment. These medias generally contain really great nutrients, a little bit of fertilizer, and various bits of sugar available and can really help your compost. Okay. All right, so hopefully I've given you some ideas for how to sort of reinvigorate your laboratory to have a little bit more of an environmental leaning. I'm going to just quickly blow through some resources, and then you guys are welcome to ask me some questions. So first of all, please check out the American Chemical Society under their Green Chemistry tab. They have this really cute, awesome wallet pocket guide that has all the 12 principles listed. And then it also has just some key notes about green chemistry. And I love these little things. So if you're curious about the history of green chemistry or the future, where it's going, please take some time to check out the Center for Green Chemistry and Green Engineering at Yale. This is the heart of green chemistry and where it came from. If you don't currently have hazardous waste disposal and this talk has inspired you to collect that waste, you can use this tiny URL to take you to this website. Resource Conservation and Recovery Act information will help you find a space nearby where you can properly dispose of hazardous waste that you've been hanging on to. Of course, the ASBC, American Society of Brewing Chemists, I use your methods almost daily, and I use your website easily every day or every other day. So if you aren't already, but I'm assuming you are because you're here, please consider joining and being a member of this really excellent resource. MBAA, also an excellent resource, but specifically for this talk, MBAA cost analysis of iso-octane reclamation. Highly recommend downloading this PDF. It has a full breakdown of what equipment you need, how to use it, how to run the reclamation, and then looking at the cost of savings and the cost of labor when it comes to reusing your iso-octane. Some resources from me. So every single piece of equipment that we've talked about today is on this Green Chemistry Amazon wish list. go ahead and write that down and check out the wish list. It will have, like I said, everything that I've recommended today. Just beware that when you put it in your cart, it's possible someone else has already purchased it. So you will get a little notification from Amazon that says, hey, somebody already bought this. Just make sure that you have it in your cart and not coming to BrewLab. Along those same lines, I have a pH and titratable acidity wish list available on my website that talks you through how to select a pH meter, how to use titratable acidity if you already have a pH meter, and then there's also Amazon wish list there. If you are more curious about the history and the science of microwaving micromedia, please check out my YouTube page that has a video of me talking about it. Or you can catch me live November 11th at 1 p.m. Pacific at the Brewing Science Symposium. I will be giving the microwave talk. If you like my talks and you want to see more of me, I will be doing another virtual webinar with the ASBC with Amy Todd from Zymology Labs. We're going to be talking about the science of sensory, and I will be covering the theory, and Amy will be covering the practice. So check us out December 1st. And then lastly, if you are in the Northwest, please come see me at OMSI After Dark, December 7th. I will be doing some science demos in real life. Lastly, I'd like to give special thanks to Julie Smith and Brian Mowry of ASBC. Thank you both for all your hard work and effort. I love these webinars, and I'm so excited to be a part of it. Huge, huge thanks to Amy Todd from Zymology Labs, who encouraged me to apply for this speakership. And then, of course, two of my mentors, Julie Hack, who mentored me through my chemistry degree and introduced me to green chemistry and has continued to be my mentor through life. And then to Terry Ferendorf, who of course founded Pink Boots, but and paved the way for women in beer, but more personally paved the way through women in beer in Eugene, Oregon, where I'm based out of. So massive thank you to these five. And then special thanks to these beer scientists who inspire me every day, who I'm not going to get worked up. I think that a lot of people sit back in out of the limelight, but these are people doing excellent work in beer chemistry and beer science. And I implore you to check them out, because knowing them is going to make you a better brewer and a better scientist. So once again, I am Dana Garves of Oregon BrewLab. You can contact me with Instagram or Twitter if you must. I have a YouTube page. You can email me or text me at this number. I try to make myself pretty available for other scientists who are seeking more information.
Awesome.
And
Thank you so much, Dana.
that's it. Yeah.
I am sorry I got your name wrong. My brain did a nervous thing, but I think we're recovered from that. So
I'm really not worried, I promise.
We've got some good questions already. And if you don't know where the Q&A box is, it's on the bottom ribbon. It should be the third or fourth icon from the right. So if you're looking for that and want to ask a question, let me know if you can't find it. Let's see. Do you find the results are the same results with the isooctane reduction across all beer styles, like double IPAs or hazies, lagers?
Yeah, I haven't had any issues, and I have been TTB certified using this method since 2014. So I am the poster from 2008. I did look for it, but I couldn't find it. I think it's on MBAA. They go through and they test different quantities of isooctane with like a number of different styles of beer. So I'm personally, I can't attest to that, but I know that I have been certified on a number of different beers, and that this paper specifically that inspired me to switch is covered different styles.
Awesome.
Great question.
How are you cleaning the glass Petri dishes?
So I get rid of the media, and then I do just a general like dishwashing scenario. Then they get dipped into alcohol, and go from there. But everyone's going to have their own method for how to clean and sterilize those.
Let's see, another media related question. Can all media relevant to brewing microbiology that needs to be sterilized, can all of that be prepared in the microwave?
So I have only looked at comparing to pressure cooked media. I have looked at UBA, so universal beer agar, WLD, so water steam differential media, HLP, so Sue's lactopdo media, and then the, I don't know what FP stands for, or I should, but the diastaticus media. What I did is, and you can find this in my microwave talk, is compare micromedia prepared in pressure cooker versus prepared in the microwave, and found in most cases that all the growth happened the same, although there is evidence, and in my experience, some of the microwave media actually grows bacteria faster. But again, I recommend you check out my talk on that. So I haven't tried like MRS, I haven't tried LMDA. I think there's a few other popular medias that I just haven't tested against, primarily because I hate pulling out my pressure cooker now. But I am so curious. I would love to do a collaboration with any other scientist that wants to look at comparing autoclaved or pressure cooked media to microwaved media.
Awesome. And we did get confirmation the FP for the diastaticus medium is Farber FAM.
Okay, yeah, I knew it was a Farber or something, but I'm not going to commit to something I'm unsure of. But thank you, audience, for that.
Can you still use the microwave to make media for pour over plates?
Yes, I prefer streaking or using the vacuum filtration cellulose, but you can of course time it so that when the media is cool, you can do it with pouring. Yeah.
Awesome. Do you have any recommendations on approaching the higher ups on implementing things that might cost a little more upfront but follow the green chemistry principles?
Yeah, I think that so part of the reason that I love green chemistry is so much of it keeps in mind labor costs, energy costs, environmental hazards, or, I think that you can utilize some of this logic to say, hey, yes, we're going to have to spend an extra $300 or $400 for this piece of equipment or implementing these things, but over time we're not going to have injuries. Insurance loves it if you are able to get rid of your pressure cooker. I think that there's a lot of ways, especially the money saving and the budget saving, that in order to get to environmentalism, or in order to reduce our greenhouse gases, we're going to have to invest. So if we invest now, it's going to be cheaper than if we invest later. I hope that answers your question, because that is a huge barrier to implementing some of these changes. I recognize that.
Let's see. Lee had some issues when reclaiming and filtering isooctane with the product. After filtering, it was reading negative IBUs when compared to the stock solution. Do you have any suggestions for troubleshooting that?
I would look at maybe what you're packing the column with, and maybe revamping some of those ratios. But it is actually not something I do. It is something that I've looked at, but disposing of my isooctane waste here safely is very cheap. I've never spent more than $27 on, I think, 8 to 9 liters of it. It is something that I'm interested in implementing into my lab, but I I think that there are some safety considerations when you have a separatory funnel full of isooctane just hanging out in the lab, that leaves me pause. And so I wish that I had better recommendations for you, but please check out that MBAA resource that I posted. They have some really good ideas about what to do when you reuse isooctane.
Awesome. What is your source for glass media plates and centrifuge tubes?
Amazon, actually. But I'm pretty sure, I don't think Weber Scientific has the centrifuge tubes, but they do have the Petri dishes.
Awesome. How can green chemistry be used in the brew house?
Oh, that is good. That's a good question because I submitted it. So one of the things that you can do is you can reevaluate the chemicals that you use for cleaning or that you use for sanitizing. And you know, every brewery is going to be different. So your answer for what's greener might be different than your next door neighbor brewery. So go through and look at what the environmental impacts are, what the hazards are, and see what's right for your brewery. It's always good to just sort of every few years re-audit the chemicals that you use. Another way you can consider switching to bulk products so that we're using less plastics, or the grain bags they can really stack up, right? So if you can switch to super sacks to reduce that plastic waste. You can also, if you are a direct fire brewery, you can consider, you know, whether natural gas or propane is better for you in terms of the environment and renewable feedstocks. And, you know, in terms of packaging, switching away from like PackTex and other plastic ways of getting beer to consumers into cardboard, I think is another really good way.
All right, well, that looks like the end of our question list, which is great. I think we got some really good information out there. So I'd like to just wrap up with some important information. First, thank you for attending today. A recording of this webinar will be available on the ASBC website. And I wanted to take a moment as we close to inform you about upcoming events from the ASBC. Your key ingredient for sustainable production, water. That's going to be on November 15th, 2022 at 12 p.m. Central Time. And then, as Dana mentioned, the Science of Sensory from Theory to Practice will be on December 1st, and that will be at 2 p.m. Central Time. Snap, Crackle, Poppin' Cans, an Introduction to Pasteurization. That'll be on December 7th at 11 a.m. Central Time. Lab on the Cheap, Microbiological Method Focus will be on February 16th at 12 p.m. Central Time. Again, thank you for attending, and thank you, Dana, for that great presentation, and we hope to see you at the next ASBC webinar offering.